Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam IFM, Investments and Financial Markets. A policyholder owns a variable annuity contract with death benefit features defined as follows. A. Guaranteed minimum death benefit, GMDB, with return of premium. The greater of the account value in the initial investment will be paid when the policyholder dies. B. Enhanced income death benefit guarantee. 20% of the account value in excess of the initial investment amount will be added if the account value is greater than the initial investment when the policyholder dies. Let T be the random variable denoting the future lifetime of the policyholder. Let K be the initial investment amount of the variable annuity contract. Let S sub T be the value of the policyholder's account at time T. You are given that T follows a distribution with probability density function f of T for T greater than 0. Given that T is equal to T, P of T is the value of a European put option based on account value S sub T with strike price K. Given T is equal to T, C of T is the value of a European call option based on account value S sub T with strike price K. Determine which one of the following statements is true. And we have the total death benefit payout for death at time T can be expressed as the maximum of S sub T and K plus 0.2 times maximum of K minus S sub T and 0. Or the total death benefit payout for death at time T can be expressed as maximum of S sub T minus K and 0 plus 0.2 times the integral from 0 to infinity of P of T times F of T dt. P of T, remember, is the value of the put. C, the expected value of the death benefit can be expressed as K plus the integral from 0 to infinity of C of T F times F of T dt plus 0.2 times the integral from 0 to plus infinity of P of T F of T dt. D, the expected value of a death benefit can be expressed as K plus the integral from 0 to plus infinity of P of T times F of T, the density, dt plus 0.2 times the integral from 0 to plus infinity of C of T F of T dt. And E, the expected value of the death benefit can be expressed as K plus 1.2 times the integral from 0 to plus infinity of C of T F of T dt. And here's a solution. So guaranteed minimum death benefit with return of premium pays the maximum of K and S sub T at time capital T. Enhanced income death benefit guarantee pays 20% of the account value in excess of the initial investment amount if the account value is greater than the initial investment when the policyholder dies. Thus, if S sub T is less than or equal to K, the amount paid at time T is K, and if S sub T is more than K, the amount paid is 1.2 times S sub T. This is analogous to a payoff of K plus 1.2 calls on the account value with exercise price of K. That's exactly answer E. So here is that answer E. The expected value of the death benefit can be expressed as K plus 1.2 as the integral from 0 to plus infinity of C of T F of T dt. Remember, F of T is the probability distribution, the density of probability distribution that refers to mortality. And then upon death happening, the payout is related to the call value. It ends up being 1.2 times the call value. And of course, if the call is worthless, then you can see that the payout is just K. And so obviously we have a payment of maximum of k and s sub t plus that 20% added to 1 to make it 1.2. So the two options are built in this formula. One is by having k plus the call payout 1 of the 1.2, and the other one by having 0.2 times this integral of possible payout of the call, and together they give us the answer that we see. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.